Guys, um, I am traveling back today from Florida, so I will see you all tomorrow. Today, you get to watch a great video about factoring. Chapter 7 is all about factoring. Today, we're just going to do some pretty common factoring. We're looking at the GCF and a little bit of factoring by grouping. So it's not too difficult. You've done some of these, back since like fourth grade or so. So factoring is just the reverse process of multiplying. It's like saying these two things multiply to make whatever you started with. So in the product 2 times 3 equals 6. 2 and 3 are the factors. They're the two things that were multiplied to make the product. So here are some examples of some factoring. There's multiple ways to factor x to the fifth. This is one of the factored forms. And again, there's multiple ways to make 6. This is one of the ways. It could also be 1 times 6, right? And then here's another way. So we're just looking at things and we're going to factor them. So we're going to start with factoring a list of numbers. And some of these you'll probably be able to do by inspection. But if you had some really large numbers, this is the process that you'd want to go through. So I'm going to do a couple of them by going through this process. And what I like to do is create factor trees. So like 28 is 4 times 7. 7 is prime, so I would circle it. 4 is 2 times 2, and those are both prime. So the factored form of 28 is 2 times 2 times 7. And then 40 is 4 times 10. Neither of those are prime. 4 is 2 times 2. Those are both prime. And 5 is 2 times 5. Those are both prime. So the factored form of 40 is 2 times 2 times 2 times 5. And then you look at both lists and you see what's in common. Well, they both have 2 2's in common. So that's the greatest common factor. 2 times 2, 4. 4 is the biggest thing that would divide both of those. Now, you could probably just look at 28 and 40 and know the biggest thing that would divide both of those is 4. But this is how you would do it. If we look at the next one, I'll do factor trees of that as well. That would be 5 times 11. Both of those are prime, so that's the only way to make 55 using prime numbers. 21 is 3 times 7. Again, those are both prime. So we see there's nothing in common, right? This is 5 and 11. This is 3 and 7. Nothing's in common. So the GCF, the biggest thing that divides both of them, is 1. And then number 3, we have 3 numbers. It doesn't really change the process. 3 times 5 is 15. Those are both prime. 3 times 6 is 18. 3 is prime. 6 is not. Continue with it. So that would be 2 times 3 times 3. I like to put it in numerical order. Makes it easier for organization. And then last 66 is 6 times 11. And that's 2 times 3. All of those are prime. 2 times 3 times 11. And you just have to inspect all 3 of them. The only thing that's in common is a single 3, right? We almost had a couple of things, but between the 3 of them, there's only one 3 in common. So 3 is the biggest that would divide those 3. So why don't you try the 4, 5, and 6. Pause the video right here, do them, and then we will compare answers here in just a second. All right, so looks like I've got 6 on number 4. Nothing was in common on 5, so again, 1. This one, each of them had at least 2 2's, so 4 was the biggest that divided each of those. All right, so make factor trees, especially if the numbers are big. Next, we're going to add in some variables. It's not difficult. It looks hard, but it's really not. And I put the key right here. The greatest common factor of a list of common variables raised to powers is the variable raised to the smallest exponent in the list. So if they have letters in common, you're just going to find the smallest exponent, because that would be the biggest that could divide each of them. And remember, when you divide exponents, you're really just subtracting the exponents. So the 3 doesn't have to go into 5 or 7, right? We're just looking at what's the smallest one. X cubed is the smallest one, so that would be the GCF. I could divide all 3 of those by x cubed, and that's the biggest thing I could divide them by. On this one, the smallest exponent is right there, y. And on number 3, z to the 4th is the smallest exponent. On 4 and 5, we add in variables, so we're going to do it piece by piece. We're going to start by looking at the coefficients, the numbers in front, and then we'll look at the variables. So let's start with the coefficients. 6, 10, and 8. The biggest thing that divides those three are 2. And we don't really care if that's a negative or not. We just kind of ignore it, and we're just going to divide by the biggest number. So 2 is the biggest that would divide those three. What's the biggest variable that would divide those three? Again, it's the one with the smallest exponent. It's x. So 2x is the GCF. On number 5, start with the coefficients. The biggest number that will divide 18, 63, and 27 is 9. And then you find the smallest y, and it's right there, y squared. So 9y squared is the GCF. On number 6, we've got multiple variables. That's no big deal. We just do it, again, piece by piece. Look at the a's. What's the smallest a? 3, 5, or 6? Well, clearly 3, so a cubed. And then look at your b's. B squared, b, and b squared, the smallest, is right there, b. A cubed b would be its GCF. Number 7, start with the coefficients. 5, 15, and 20 are all divisible by 5, and the smallest y is y squared. On number 8, the biggest thing that divides 4 and understood 1 and 3 is, of course, 1, but I'm not going to put the 1 because it's understood. And then look at the variables. X squared is the smallest. And then on number 9, looking at the a's once again, a squared is the smallest, and b squared is the smallest. So a squared, b squared would be the GCF for those. So we're going to take these GCFs one step further here, and we're going to actually factor out the GCF. So we're going to make a multiplication problem. So we're doing like the reverse process of the distributive property. So we're going to factor out the GCF, and then we're going to write what would be left in parentheses. So we do this like we did above. What's the GCF between 6t and 18? We'll start with just the coefficients, the numbers. What divides 6 and 18? The biggest, we're doing GCF, is 6. 6 divides them. Now you could say 2 or 3, but that's not the biggest, so it has to be the biggest. 6 is the biggest. And then you're going to imagine dividing each of these by 6 and write what would be left. So if you take 6t and divide it by 6, that's going to leave you with t, so we put that in parentheses. And then 18 divided by 6 is going to be 3, and we put the plus sign in between. And these are very easy to check. If you were to redistribute that 6, would it make 6t plus 18? Well, yeah. So we're just doing reverse distributive property. We're going backwards, all right? Number 2, we've got just 2 variables. Remember, again, the GCF of variables is the smallest exponent. So y to the 5th is the smallest exponent, so we're going to write that. And then we start a parenthesis. If we took y to the 5th and divided it by y to the 5th, that would be 1. And then minus y to the 7th divided by y to the 5th. I just think of this, remember our rules for exponents. When we divide, we really subtract our exponents. If we have 7 y's and we take 5 of them, how many would be left? 2 of them. So there you go. And then again, you can imagine distributing. Would it give us that answer? And yes. Number 3, again, the biggest thing that divides is 4. If we were to divide by 4, that would be t plus 12 divided by 4, 3. Number 4 is like 2. Take the smallest exponent, that would be y to the 4th. Then we really are subtracting. 8 minus 4 is 4. And y to the 4th, if we take all of them away, we do need the understood 1, because if we were to distribute it, there has to be 1 times something to create that y to the 4th. All right, number 5. We're getting a little more complicated, but it's really not too bad. We don't want our first term in the parenthesis to be negative, so if the first term of the polynomial is negative, we're definitely going to factor out a negative. And then we're going to go through our process. What's the biggest number that will divide 9, 18, and 3? And of course, 3 is the biggest. And then with your letters, the smallest exponent is that a on the end. So we're going to take and divide each term by negative 3a. So negative 9 divided by negative 3 is positive 3. And that's what we want. We want this first term to be positive inside of the parentheses. That's standard form. And then the letters. A to the 5th, we're taking one of those a's away. That would be 3a to the 4th. A positive divided by a negative is a negative. 18 divided by 3 is 6. A squared, take one of them away, leaves us with a. And then a negative divided by a negative is a positive. 3a divided by 3a, of course, is going to be 1. So that's going to be plus 1 on the end. Number 6 is much like number 5. Why don't you pause the video here and try number 6. All right, negative 8b squared is the GCF. If you were to divide each of them by negative 8b squared, you would get b to the 4th minus 2b squared plus 1. Oops, there you go. All right, a few more examples down at the bottom. Number 7, this is really no different. We'll do 7, 8, and 9 together. Then I'll have you try 10, 11, and 12 because they're just like the ones above. So 7, what's the biggest that divides 6 and 12? 6. What's the biggest that divides a to the 4th and a? A. If we divide 6a to the 4th by 6a, 6 divided by 6 is the understood 1. A to the 4th, take the a away, is a cubed. And then 12 divided by 6 is 2. We're taking all of their a's away, so that's what it remains. Number 8 is fractions, and fractions are not that difficult. Since all of our problems are just going to have that same denominator, so we're always going to take 1 over whatever the denominator is, 1/7. So down here you're going to be doing 1/9 since the denominator is 9. And then look at the letters. The smallest is x squared. And we know what happens when we divide a fraction by a fraction. We flip and multiply. So the 7s would cancel, and it's going to leave us with whatever the numerator is. So this one's going to be 3, and then x to the 2nd because we're taking 2 of them away. This one's going to be the understood 1 for the numerator. But we don't need to put that because we're going to have some more stuff. X cubed, take 2 of them away, is x. And this one's going to be minus the numerator 5. And we're taking all of the x's, so that's what that one would remain as. Then number 9, it's actually probably easier than 8. What's the biggest that will divide 15, 20, and 5? Of course, 5. And then the smallest p is p squared, and the smallest q is q to the 3rd, q cubed. Divide each of those by that number, and you would have 3q plus 4pq squared, and then plus 1. Awesome. So you try 10, 11, and 12. Pause the video here, and we will compare answers in just a second. All right, so here are my answers. I got 5x times x cubed minus 4, 1/9 z cubed times 5z squared plus z minus 2, and then 4ab cubed times 2ab minus 5a squared plus 3. And then again, on all of your problems, you can check your work by just imagining distributing that through. Would it give you that original solution? Okay, so we're going to move on to page 3 here. And this is going to be setting us for factoring by grouping, which we'll see down here just at the bottom half of this page. So these ones look more complicated, but they're really not. We've got 5 times x plus 3 plus y times x plus 3. So what that means is there is an x plus 3 in common. So we can factor out that x plus 3 from each of those 2 terms. That really is 2 terms. And if we were to take an x plus 3 from each term, so imagine these are gone, what's left? Well, the 5 plus the y. So that would go in the second parenthesis, and that's what these factors do. That's what we're going to see down here when we do factoring by grouping. It's going to be set up like this, and that gets us to a nice factored problem. So again, on number 2, a plus b is in common, so it's going to be factored out. So they're kind of gone now. What's left? That has an understood 1. So this would be 3m squared n minus 1. All right, and then 3 and 4 follow the same thing. You can pause the video if you want and try them. I'm going to go ahead and get started on them, so pause it real quick. There's the y minus 2 in common. If you were to take the y minus 2, there would be a 8 plus x left. On number 4, there is a p plus q in common. Understood 1 there, leaving you with the 7xy cubed minus 1 left. Okay, so that leads us to factoring a 4-term polynomial by grouping. So here are the steps. You can read through those. I'm just going to kind of show you them as we do these example problems. Okay, so the first step whenever you're factoring by grouping is there a GCF? So that's always your first step. Is there something that divides all of these terms? I don't see anything that would divide all four of those terms, so we just go into factoring by grouping. And it's very simple. What you do is you group the first two terms of the polynomial, and you group the second two terms of the polynomial. That's why it's called factoring by grouping. And then you look at each of your individual groups, and you factor out the GCF from those. So what's in common between xy and 2x? Well, clearly an x. If we were to factor an x out, that would leave us with y plus 2. And then if we look at our second group, what's in common there? 3, and that's a positive 3, so you're going to put plus 3. And if you were to divide each of those by 3, that would leave you with y plus 2. And then you notice it looks a lot like the problems that we just did, right? There is the y plus 2 is in common. It's in both parentheses, so you can factor out that y plus 2. And then what would be left? The x plus 3. And there you go, it's factored. And again, you can check your work by foiling this out, and you'll see that it does in fact create that original polynomial. So we'll do 2 again together. Again, first step, is there something that divides all 4 of these? There's nothing that's in common with all of them, so we go ahead and group the first 2 and group the second 2. If we were to divide, look at the first one, there is a y in common. If we divide that y out, it's x plus 3. And the second one, there is a 4 in common, which leaves us with x plus 3. Again, those parentheses match, so that means we can factor it to x plus 3 times what's left over, y plus 4. And then number 3. Again, first step, is there something in common with all 4 of them? Almost. They almost all have an x, but they don't. So there's nothing in common with all 4 of them. And then we're going to group them. Okay, so we look at that, and what's in common with those first 2? There is an x in common. And if we take an x, there would be 3x plus 4y left. In the second group, again, you don't want your first term to be negative, so we're going to at least factor out a negative. And then I don't see anything else in common, so I go ahead and put the negative 1 just because I don't want to forget that there is a 1 out front. If I divide each of those by negative 1, it would be a 3x plus 4y. And then look, those parentheses match, so that's good. So we can factor out that 3x plus 4y, leaving us with an x minus 1. So why don't you try number 4. Go ahead and pause the video, and we will compare. Okay, so I got 2a plus 5b times a plus 1. And so this one was a little bit tricky because there was nothing in common, and they were already positive. So you'd really kind of factor out a positive 1, which gives you that a plus 1 for your second factor. So hopefully you got that. 5 and 6 are going to follow 3 and 4. So again, I'm going to pause the video. You check those out. Try those, and we'll check here in just a second. Okay, you can see my answers here. 2x plus 3y times y minus 1, and 7a plus 5 times a squared plus 1. So hopefully you got those. All right, let's look at these last 4 problems. See if there's anything going on with them. Okay, so let's see. First step, is there anything in common with all 4? And I see no. So let's factor those by grouping. Is there anything in common with that first group? No. Is there anything in common with that second group? Negative 1, but that's not going to make it match. So this is one where it's not quite in the right order. If you notice this, this problem, it's really not in standard form. So my first step here really is going to be actually to rewrite it in standard form. So I'm going to put the x, the y, and then that normal number. And that looks nice because I've got my 3's that match and my 2's that match. So that means there's definitely going to be some factorable things. So now that it's in a better order, we're going to be able to probably factor it out, and it's probably going to be able to work out for us. So a little hint is, if it's not in highest power to lowest power, you probably want to rewrite it in that case. Um, so yeah, especially if you look at the groups and nothing's going to factor. So in that first group, there is a 3x in common. If I divide those by 3x, I would have y minus 1. In my second group, it starts with a negative, so I know I'm going to definitely take out a negative, and then there's a 2 in common. If I divide by negative 2, that would be y minus 1. And you see that those do match, so we have that y minus 1 in common times 3x minus 2. That would be left over. Now number 8, it's not quite in the right order, but I do... so I'll probably go ahead and just put it in the correct order. So I would put x cubed first, x squared second, 5x third, and 10 last. That really doesn't change the order much because our two groups are going to be the same. But I do like to put it in highest to lowest because that usually solves some problems. So we're going to go ahead and group. There's an x squared in common. That would be x minus 1. There's a 5 in common. That would be x minus 2. That doesn't match. So that's not good. See how that doesn't match? Maybe we need to switch some order again. So that's what step 3 says. If there's not a common binomial factor in the groups, you got to rearrange and try those steps again. So a lot of times if you just flop the middle 2 around, so I'm going to flop those 2 around, that will work. And if that doesn't work, then I don't know what to do. So let's see, if we flop those guys around, or maybe, yeah, let's do that. Okay, so if I flop that, it would be x cubed plus 5x minus x squared minus 10. All right, let's group those up. So that would be an x in common, leaving us with x squared plus 5, and a negative x, no, just a negative 1 in common, leaving us with x plus 10. And again, that doesn't work. So I'm seeing, oops, I'm sorry, that wasn't on the screen the whole time. I'm seeing that, again, they don't match. So if you try it a few ways and it doesn't work out, sometimes they're just not factorable, which this is the case there. Okay. Number 9. We're probably not going to do 10 just because I don't want this video to be too terribly long. You try 9, we'll compare answers here, and I bet you probably have to rearrange it, so go ahead and do that. Alright, so it turns out you did not have to rearrange that, and it did work, and I did put mine in a different order. If you have x minus b times 4a minus 2b, it's the same thing, right? 4 times 5 is the same as 5 times 4. So there you go. I was looking ahead. 10 does factor pretty easily. We can do that one real quick. 3y is in common, leaving us with x minus a. And then negative 6a is in common, leaving us with x minus a. So you get a final answer of x minus a times 3y minus 6a. So there you go. All the problems are done. You check them, and you can get started on your assignment in my math lab. And I'll see you all tomorrow. Thank you for watching, and good luck tonight.